Good afternoon, everyone. Thank you for inviting me instead of JanCon. Most of you don't know me, but I've been working with Jan for more than 10 years already, and we have been working in Peru, in the Peruvian Amazon for, I would say, like 7, 8 years. I'm going to present some of the data, but first of all, I'm going to show you some evidences of the changes and shifts of exophagy and Anopheles malaria vector around the world. Most of this information is published, and I just make a brief. I'm going to make a brief mention, but I think it's interesting to look. How can I? How can I change the? No, this is the. Is this it?
That's not it.
How do we move the slide?
This one, right?
Okay, thank you.
Great. Okay, so thank you, Michelle, for the introduction. And as you know, most of the malaria intervention to reduce mosquito-human contact are based on long-lasting insecticidal nets and also on insecticide residual spraying. And despite the extensive use of these two strategies, we still see that there are some malaria transmission. And if we ask why, is because IRS only affect mosquitoes that are resting inside the houses, and ITNS only affect mosquitoes that are biting during the night. Also, both interventions will mainly affect mosquitoes that feed on humans and also that are feeding inside the houses. And in the mosquito population, we have a fraction of mosquitoes that naturally are exophilic, zoophilic, or exophagic. And these mosquitoes are not going to be affected by any of these control measures. So behavioral resistance is a concept that is not new, but actually it refers to any modification of the behavior of mosquitoes related to this, to the pressure of insecticides against the mosquito. In this case, bed nets, impregnated bed nets, and IRS. So one of the important things to see or to know is that depending on the insecticide product and we're going to have different outcomes of the mosquitoes, and these changes of the behavior phenotypes are, let's say, they're going to produce avoidance of the contact of the mosquito with the insecticide. So you see here we have 4 mainly changes that we can see in the mosquitoes or outcomes. We're going to see a species shift. So we can see there are an alteration of the taxonomic composition of the in an area. We're going to see a shift in early biting. So these mosquitoes are going to avoid contact with. Are going to have more contact with people that still are not under bed nets. We're going to see a shift to exophagy, which means that mosquitoes are going to have a tendency to bite outdoors better than indoors. So these mosquitoes, they're not going to have contact with insecticides or with any bed nets. And also we can see change towards zoophily. And it's these mosquitoes that usually bite on humans, feed on humans, they can change and feed on another animals or hosts that they're around, like cattle or any other animal around. Other important thing that I want to stress out is that this kind of behavioral resistance, it's because of the short regeneration time of mosquitoes. We can see in short time we can detect these changes. Okay, so I'm gonna, as I mentioned, I'm gonna just briefly name some of the studies that were providing evidences about this shift in exophagy. I'm not going to focus on the other 3 outcomes that we can have just in exophagy, and I'm going to divide in Afrotropical, in Eurasia, and Neotropical mosquitoes. So as I mentioned, this is not a new question. More than 40 years ago in Nigeria, the spraying with Proposure already provide information about the mosquitoes who were biting outside. Also in Kenya, the use of intensive ITNs proposed that mosquitoes were biting outdoor. In Gambia also, there were chains toward outdoor mosquitoes biting. And in Bioko Island, and I know that Jake Myers is going to talk more about this, we also have chains to outdoor mosquitoes. However, we also find like some mosquitoes that they don't have evidence of changing in the same areas. Even in the Gambia, we have like different studies providing evidence, and some others that we don't see any evidence that the mosquitoes are biting their behavior. So I'm gonna I'm gonna show you these 3 examples about the change in biting profiles in different mosquitoes in Africa. The first one is going to be in Tanzania, and they were working after 12 years of intensive bed nets distribution. We were checking and recording the change in biting profile in Anopheles gambia and Anopheles funestus, and what they found is that Anopheles gambia maintain the indoor behavior, but they can see that the mosquito bites like throughout the night and not only at the end of the night. But what is interesting is that Anopheles funestus, they could see that they have a significantly decrease in indoor beating. So the mosquitoes were more prone to bite outdoors, and actually there was a peak in the activity of these mosquitoes where people are not still on their bed nets, so they are not protected. So this means that there could be more malaria transmission, and these mosquitoes are not target to control the disease. A second example, it's in Benin. They were focused also on Anopheles funestus, and after 3 years of bed nets distribution, they saw that the Anopheles funestus bit later in the night, and also they have more outdoor preferences for biting people. As I mentioned before, you can see like a fast change in this mosquito behavior. And also, this is not really exactly changing outdoor behavior and outdoor biting behavior, but I want to illustrate that you can see that Anopheles funestus just change their biting habits and start biting during the day, even they were collecting from 7 to 11 a.m. and they have a lot of mosquitoes, almost like 6 times like what they have like during the night. I have to stress out that these mosquitoes still were biting indoors, but they biting during the day. Also, we have a lot of information regarding Australasian and Oriental vectors. We have very nice and very robust information of Anopheles farauti in Papua New Guinea, and presented by Charles and Russell. That has several studies showing this evidence that Anopheles farauti already bites outdoor. We have in Thailand also that after spraying, we have Dirus and Anopheles minimus that change their biting behavior. We have in China Sinensis, Leicesteri, and minimus, and we have in Vietnam also with Dirus, maculatus, and minimus groups. And in contrast, we have in Laos that Anopheles dirus didn't work like the other ones, and they didn't change their behavior. So if you see, there are like some of the mosquitoes and many mosquitoes, so they have like a lot of heterogeneity, and not always the strategy affects the same to the populations. And finally, I'm going to talk about the tropical vectors, and I'm going to show you some preliminary data that we have in Peru. So we have very few information in South America or in Latin America, neotropical vectors, and this is for different reasons. One of the reasons is that we don't have in many of the places we have hypoendemic malaria. So ITNs and IRS is not as extended than is in African countries or in other parts where the malaria is hyperendemic. And we have also a different composition of vectors. For example, if you see here in Brazil, we have Darling that acts like biting outdoors after IRS. In Colombia, didn't happen like that. And we have also an example in Suriname that the combination of ITNs and IRS produced the collapse of the population, but it was like at the same time that a flooding event, so actually there is kind of like a confinement effect. So I'm going to show you, like I said, some preliminary data from Anopheles darlingi in Iquitos, in the Peruvian Amazon, and I'm going to show you that we have the opposite trend right now. So Anopheles darlingi, it's biting indoors again. So here's the situation we have here in Iquitos, and we were working in this region for more than 7-8 years. We have previous information from the Darlingi population in the 96 and 97, and we have they were biting outside and inside the houses. The ratio was like 0.5, and after 10 years, there was a program that they were providing insecticide threat nets to everybody, like an extensive distribution. And after that, in 2011, 2012, we see that Anopheles darlingi was biting mainly outdoors with a ratio between like 0.8 and 0.9. So there was almost nothing of transmission inside the houses. But also we were testing that if our population were susceptible to insecticides, and there were, so we don't have any problem. But what is interesting is that from 2013 and 2015, we start to see another trend of the mosquitoes. So we were focused on these two villages, this Lupuna and Cauide, and for these 3 years, and we were checking these two behaviors, biting indoors and outdoors. And we were dividing the night or the collection timing for periods like early night, midnight, and early post-night and early morning. So we were doing analysis based on abundance of this of the mosquito in these 3 years, and we were taking different variables. We were taking endoxophily, the year, the time of period of collection, the village, and all these interactions. And what we see is that the significance was really high for all of them, but the endoxophily was like really providing information about the biological meaning of these mosquitoes. So when we were checking the ratio of mosquitoes biting indoors and outdoors, if you see, this is Lupuna, this is Cauide, and this is 2013, 14, and 15. So we see that the ratio in 2013 was like 0.34, and in only 2 years we have the double outcome for the same population. And we have the same trend in Cauide. We have a ratio of 0.35, and we have the double in only 2 years, which means that the mosquitoes are significantly biting more indoors. So this is another way of see the same data. We see in red is Cauide, and in blue is Lupuna. We have the year distribution of the ratio. So we have like some variation between these two communities, but we can see here perfectly the trend of the mosquitoes biting more indoors. Also, what we want to see if there is how the mosquitoes are dangerous for the transmission. So far we only have analyzed 2014 because we have a lot of mosquitoes, but we are working on 2015. And what we can see in Cauide is that, the first thing that I want to see here is that both communities have the same trend, the same biting profile, indoors and outdoors for the mosquitoes. But the difference between both of them is that in Cauide, most of the mosquitoes were collected before 11 in the night, where people are not under bed nets. And in Lupuna, we have like 2 different mosquitoes infected. So we have one at 8 p.m. and one during the night from 2 to 5. So in this case, people are under bed nets, are protected, but in this case, they are not. And here in Cahuide, most of the mosquitoes were infected where people are still around. So the other thing to take from this slide is that in both communities, the risks were similar indoors and outdoors. So we found mosquitoes infected indoors and outdoors, not only indoor mosquitoes. And to link the vector behavior with the malaria that we have right now there, so in the last 3-4 years, we have an exponential increase in malaria cases in the Peruvian Amazon mainly, and we have from around like more than 60,000 cases. What is interesting is that, as you know, in the Amazon, most of the infection are because of Plasmodium vivax. We have more than 80% of the infection for Plasmodium vivax. But in the last year, we have seen an increasing of Plasmodium falciparum. In this community, we have like double cases than the other years. And in this other community, in Lupuna, we have 4 times more cases of Plasmodium falciparum than the previous years. So we don't know yet why this is happening. We don't know, and we think that it is related to some of the mosquito behavior, which is like very interesting. So we have some questions still. We're working on that, and I would love that if you have like any idea to see what is really happening there. So we have like 3 main items. I have 3 main evidence that I want to tell you. So the first one is that if you remember, in 2010 was the last time when we have like distribution of bed nets. So it's been already almost 3 years, and probably the effectiveness of the insecticide is not working. It's not working anymore, and but we don't know yet. There are no effectiveness studies in the bed nets. We're planning to do probably for next year, combining with or coordinating with the Ministry of Health. Also, the insecticide residual spraying, it was like 3 years ago, until 2012, they have like rounds of 4 times per year, but since this year they stopped to do because change of priorities in the vector control unit in the area, so they're not spraying anymore. So which means that if they are not working and they have no IRS, maybe mosquitoes are trying to buy indoors because they like moss. But what is interesting is that we have a dramatic decrease of mosquito abundance in the area. So you will think that if this is not working, mosquito population abundance is going to explode. But in this case, we don't have this. We have exactly the opposite. If you remember the other slide. So with the data that we have here, we can say that in these 2 villas we have like indoor and outdoor transmission, but we don't know exactly why we have this behavior. And the conclusions, and I'm pretty sure someone is going to say more about that. We really don't know exactly why is with these mosquitoes are changing the processes that are leading these mosquitoes to change behavior. And but we really need to develop new methodologies for trying to identify this behavioral resistance in the field. We have to take into account the heterogeneity in behavior of all these mosquitoes within and between populations. And we have to determine if this behavioral resistance is heritable, and if so, we have to try to develop diagnostic tests to try to identify in situ or as soon as possible to try to change these strategies. Also, we need to provide information constantly about like vector bionomics in the area that we are working to tailor the programs related to the vector behavior. And lastly, I want to say that we should have a multidisciplinary approach with epidemiological stratification, sociological and demographic information, and combined with mosquito and entomological surveillance to inform and to implement like difference in control interventions. And thank you very much for your attention.